Hi all, today we are going to learn about topological sorting. It is an application for a depth first search method. A topological sorting problem is defined by given a digraph G is equal to V comma E. Digraph means it's a directed graph. Find a linear ordering of vertices such that for all edges V comma W in E, V precedes W in the ordering. In other words, it can be also said as a topological sort of diag or a directed acyclic graph or a DAG as it is sometimes called is represented by G is equal to V comma E is a linear ordering of all its vertices such that if G contains an edge V comma W, then V appears before W in the ordering. Many applications use directed acyclic graph to indicate precedence among events. Now let us see it using an example. Here there is a graph which has A to E as one connected and F is a single one. Now when it is sorted using a topological sort, then it has to be A to B. The nodes or the connection should be as it is, but it should be ordered in an order so that the condition also follows. That is, for any edge V comma W in E, V precedes W in the ordering. That is shown in the right bottom corner. A to B, B to C is shown, C to D is shown, D to E is also shown, F is put in between. Now how does this happen? Let us see. And as in the box, any linear ordering in which all the arrows go to the right is a valid solution. If there are some nodes, if you when by drawing it comes to the left hand side, then it means it is not a valid one. Now, in the algorithm, the first step is identify vertices that have no incoming edges. That means the in degree of this vertex is 0. Now, in this case, in this example, A is a vertex whose in degree is 0, as well as F is also a vertex whose in degree is 0. If no such edges are there, that means the graph has a cycle. If it is having a cycle, then topological sort is not possible. So, coming back to the example, A and F are the vertices which has no incoming edges. So, select one. We have selected A. The second step of the algorithm is delete this vertex of in degree 0 and all its outgoing edges from the graph. Place it in the output. Now, as you know or you have seen in the previous slides, A had an outgoing edge to B as well as an outgoing edge to D. When A is taken into the output, naturally the outgoing edges from A also has to be removed. So that has been removed, and then the remaining is B, C, D and E. Again, the same step 1 and 2 is repeated until graph is empty. So the first step is you have to select the vertex which is having in degree 0, B and F. First you have to complete B. When you take B into the output, the outgoing edge from B to C has to be discarded. This is done here. Now C is another edge or another vertex where in degree 0, F is also there. Now we can put F, C also can be taken, or you can take directly F, no issues in that. So we have taken F because when you take C, the edge after drawing completely, the edge goes backward, which is not suitable. So F is taken, C is removed. Now D and E is remaining. D is taken. Similarly, the last one, E is taken, and so the final result is A, B, F, C, D, E. Now, just for summarizing, store each vertex in degree of incoming edges in an array. While there are vertices remaining, find a vertex within degree 0 and output it. Reduce in degree of all vertices adjacent to it by 1. Mark this vertex. This is the algorithm. So, this is how it goes. There are basically two arrays which keeps track of this. One is the in degree array, another one is the adjacency list. As you all know, A has an adjacency to B and D, B has to C only, C has to D and E, D has to E, F and E doesn't have any adjacent nodes, so those are empty. Now in the in degree array, A is taken first. Similarly, F is also there in the first step. So those are put values 0. Then when you take B, B and C they go together. Then D and E go together. So this is how the in degree array works. So you just have to go through the example and the algorithm, that is step 1 and step 2, and the last one which we have discussed, and that's topological sort algorithm. Thank you.